Looking at chapter 3 then, we begin with section 3.1 and we're looking at outliers. So an outlier is a very large value or a very small value. Now previously to this course you may be used to just looking at a set of data or looking at a scatter graph, looking for one of the crosses on the scatter graph which is a long way from the other crosses and saying, well, that must be an outlier. What happens a lot on the A-level course is that we do things where previously we've just made a value judgment, now we're going to try and quantify it, we're going to try and put some numbers to this, and that's exactly what we do here. So we need to have a definition of an outlier. How far away from the rest of the data does it have to be? And this is the definition that we're going to go for. We're going to say, well, take the higher quartile, take the upper quartile, take the interquartile range, Q3 take away Q1, upper quartile take away lower quartile, and you're at the upper quartile, use a certain multiple of the interquartile range and add that on. Okay, and if you're that far away from the rest of the data, then that we'll call an outlier. So that will be our outlier boundary. And then the same thing for the lower definition of an outlier, take the lower quartile and take away a multiple of the interquartile range. Now, the multiple, the k, is a little bit up to you. If you want to be very tolerant of outliers and accept lots of data, you make this k very big, so you can get a long way away from the rest of the data. You can get a long way away from the upper quartile and still not be counted as an outlier. If you really don't want to be interested in outliers at all and you think that there might be outliers that you want to discount from your data, you'd make k small. Now, the standard for k is 1.5. Okay, and that's exactly what they're doing in example 1 and in most of the questions in the book. It does say here that in the exam they will include the value of k, except that in some of the sample assessment material from the exam board there is a question where they have not included the value of k. They've just asked you to find the boundary for outliers or prove that such and such a value is an outlier. So 1.5 is the standard. If they don't give you a value of k, I would recommend using 1.5. We're talking about outliers there. Now, we need to think a little bit about the difference between outliers and anomalies. Okay, so the key bit is this sentence here. The process of there we go. Here, sorry, this is the key sentence. Anomalies can be the result of an experimental or recording error. That's the bit that we're interested in. Okay, so an outlier could just be a particularly high bit of data. So you're measuring, I don't know, the distance that people can long jump, and everybody's goes out and lines up and has the best go at doing a long jump, and then just so happens that walking past is an Olympic long jumper. That person can come along and will be an outlier, will jump a lot further than anybody else. But it's a perfectly well-recorded piece of data. It's a perfectly good piece of data. That piece of data will drag up the mean. If you're going to calculate the mean, it will affect all sorts of things, but it's a well-recorded piece of data. Now, you need to make a decision whether that is important or not. If the other option is that you could not have the Olympic long jumper, you're measuring everybody's long jumps, and one of them just gets written down wrongly, and a few meters are added on. So somebody tries to write down a 3 and it looks like an 8, something like that, and there's a mistake in the data collection. So if there's a mistake in the data collection, you definitely want to ignore that value and not include it in your statistics. So that would definitely be an anomaly. An anomaly can be the result of an experimental or recording error. Okay, so if you make a mistake in the experiment, if the equipment goes wrong, if you write the wrong number down, that would be an anomaly. You want to take that out of your data. If you've got an outlier, which is not necessarily an anomaly, which is not a mistake, then you need to think carefully about whether you include it or not. And there will be questions of the type of, should you include this outlier or not? Give a reason why you should include it or give a reason why you should not include it. So reasons to include it would be just, well, it is part of the data, it's well recorded, we should take account of all the data if we're going to be accurate. A reason to not include it would be, it may be an experimental error, it may be a mistake that somebody's made, or even just we're dealing with statistics. We're interested in the average person. We're not interested in if we include the Olympic long jumper, it's not going to tell us information about how far the average person can long jump. So if the question we're asking is asking about how far normal people can long jump, we don't want to include the Olympic long jumper. So partly in context, I would have said though that a safe answer would usually be Why would you not include an anomaly? It may just be a recording error. Why would you include an anomaly? Sorry, not an anomaly, an outlier. Why would you include it? Because it's a good idea to include all the data. Moving on to box plots. Now again, this is a GCSE, there's quite a bit in this chapter which is a GCSE material. I don't intend to recap GCSE material in these videos, but there are tweaks to the GCSE material which I'll just mention. So I'm sure you're familiar with the idea of a box plot. If we have an outlier, we put it on the box plot like this. We just have a single cross at the point where the outlier is. Now if we've got an outlier on the box plot, the outlier is probably going to be, the lowest data value will be one of the outliers, won't it? We might have one or more outliers, but if we have outliers at all, then one of the lowest data value will be one of the outliers, or maybe the highest data value will be. So what happens to the end of the whisker on the box plot? Well, in that case, the lower boundary for outliers is where we put the whisker. Okay, we don't put it, if we've got one outlier, we don't put this at the second lowest piece of data or the third lowest, we put it at the boundary for outliers. Okay, so the second lowest piece of data might actually be here, but this is where our boundary goes, and then the same with the top end of the diagram as well. There's no particular mathematical reason for that, it is just convention. It would mathematically, it would make just as much sense if we put the outlier there and we put this whisker at the next data value, but that's not what we do. We put that whisker at the lower boundary for outliers and we put the outliers on the box plot with a cross. Okay, that leads us on, box plots naturally lead us onto cumulative frequency curves or cumulative frequency diagrams. I don't think there's very much to add about this because this is GCSE level material. As I say, I'm not going to recap GCSE stuff in these videos, but it would be worth you just going back through this, make sure you've got the ideas clear. Remember, you're plotting the cumulative frequency is add up the frequency as you go. So you're adding the cumulative frequency against the sort of right-hand end of the class intervals. Remember, there may be situations where you have to adjust the class intervals in these questions here from 1.0 to 1.2, and then this one starts at 1.2. 1.2 is obviously the end of this class here, but if it's a situation where it went from 1 to 2 and then from 3 to 4, you might have to do a little bit of thinking about where the interval actually ends and where the interval actually starts. Very similar to what we did in chapter 2. So nothing much more to add there on frequency tables. Histograms, there is a little bit of difference, so I think we'll do that in the next section.